Yes, Sat Shri Akal, students. So today we will discuss uniform circular motion, class ninth physics. Uh, Students, in order to understand the concept of uniform circular motion, this uniform is important. Circular motion, what is the speed in this? What is the velocity in this kind of motion? And what do we say about acceleration? Let us try to understand all this. Obviously, the direction is also important. So, let's roughly imagine that this is some ground. This is some ground, and in this ground, a athlete wants to run with constant speed. See, I am saying speed. I am not saying velocity. So because it is constant speed, he can change direction, no problem. In speed, the direction can be changed. Direction can change, no problem with change of direction because speed is a scalar quantity, so it only has magnitude, right? Uh, an athlete wants to run, but he wants to run with constant speed. Now, obviously, he cannot run in a straight line 2 kilometers or 3 kilometers because this may be just 400-meter into 400-meter square track. So, but he wants to run for 1 hour or 2 hours, so he has to change direction. It's possible that he can run with constant speed. Okay. So, first case, let us say this is the way he's running. This is the way he's running. Means it's a rectangular track. So he goes from A to B, then B to C, C to D, then D to A. Now he's running here, so the speed is constant. Whatever it is. Let's say the speed is X meter per second. The speed is constant. So when he's running here, you might think, sir, here the speed will change. But you just imagine that the athlete is very skillful. Very quickly, he changes the direction and he doesn't affect his speed, though it is not possible. But you assume that he very quickly he changes from here to here. Okay. So the speed is constant. Then he runs from here. Okay. So in order to maintain the constant, he is maintaining the constant speed in one round, students. Now, how many times he changes the direction? Can you tell? In how many times he is changing the direction to complete one round of the rectangular track? Very simple.
4 times.
4 times. Very simple. 4 times he's changing the track. Okay, very good. All right. Now, students, what is happening? That second day, he thinks that no, I'm not going to run in rectangular track. He is running in this kind of track. He is running like this, like this, like this, like this. He's running like this. Okay. Now, students, what is this? This is a one, two, three, four. This is a hexagon. This is
Hexagon.
a hexagonal track. Okay. So in this hexagonal track, he runs from here again. Immediately he changes the direction. Now he maintains the constant speed. How many times he changes the direction?
6 times.
6 times.
Time.
6 times he changes the direction. Okay, students, have you observed that when time the time in which he's changing his direction is increasing, like last time it was only 4 times he changed the direction, the length of one side was quite more. Now the length of the sides have decreased. Have you observed that? If you don't observe, if you don't understand, you can always ask doubt. It is stupid of you if you don't ask doubt. Always ask doubt when you don't understand. Otherwise, other concepts you may miss. So he's changing his direction 6 times, but the length of one side is decreasing. The last time it was this much length, now only this much length. Okay, so next day the athlete comes, and students, you know, instead of taking, he takes this track now. One, then two, three, four, 5, 6, 7, 8, 9. Okay. So 9 times. Now, how many times he's changing the direction? He's changing direction
Nine.
times. Have you observed?
Nine times.
He is moving with constant speed, but more times his direction is changing, and the length of every side is again decreasing. Am I right? So instead of this, suppose it is now more. It's like one, two, then three, four, five, six, 7, 8, 9, 10, 11. If he changes 11 times, then the length of the track is further decreasing. So what you can observe, that as his mm, number of times his direction is changing, if that number of time his direction is changing, he the sides of the you know the sides of the track, whatever whatever kind of figure in which he is running, the sides are decreasing. Students, can you think that this athlete changes, please listen carefully, his direction infinite times, then what will be the shape of the track?
Circular.
Beautiful. Very well answered. Other students, can you think about this? Athlete is changing his direction infinite times. Then the shape of the track will be circular. Why? Any student can tell me why? This will be the shape of the track. Why? Because thus we have seen the, if he changes the number of times he changes the direction, the sides are coming shorter and shorter. Now he's changing the direction how many times? Infinite times. The length of the side will become, the length of the side will become a point. So you can imagine infinite points on the circumference of the circle. Infinite times this athlete is changing his direction, and what you get is a circular path. Okay, you think about this, you will get the answer. Circular path. Good. Very good answer. Now, the motion of the athlete, motion of anybody around a circular path with a constant what? With a constant speed. With a constant speed is known as uniform circular motion. Here, the speed is constant, but every single microsecond, the direction is, yes, students, the direction is changing.
Changing.
The direction is changing. But interesting thing, the speed is not changing. Now, you see, students, if you imagine an athlete who's running, you know, like this, when he takes a sharp corner, you can say that, sir, it is not really possible that the speed will be constant. He has to decrease the speed little bit, but we have assumed his speed is constant. But student, if you run on a circular path, it is possible very much that your speed is constant. Can you imagine that? But every single second, your direction is
changing.
changing. Think
Changing.
of this. Can you understand this in a deeply? When you are running on a circular path, every single second, students, your direction is changing, but it is possible that your speed is constant. All right. So that means, students, your speed is constant, but your direction is changing. That means if I take 2 points very nearby, if I am taking 2 points very nearby, 1 point here, 1 point here, at these 2 points, I want to ask students, will their velocity be constant? This is 1 point, this is 2 point. Let's say velocity at point 1 is v1, velocity at point 2 is v2. Any student, can I say that v1 will be equal to v2?
No, sir.
Yes.
Why not?
No, sir.
Why not, sir?
Direction is changing here because direction is changing.
Beautiful. v1 is not equal to v2. Students, imagine if this is v1, it is its magnitude is 10 meter per second, but direction is this. And students, imagine this is v2. Think very carefully. This v2 direction is again 10 meter per second, but the magnitude is 10 meter per second, but direction is different. v1 is not equal to v2. But students, I am telling you one interesting thing. Suppose this is a vector. Suppose this is a vector. Please listen very carefully. Its magnitude is 10 meter per second. It's a velocity vector, v1. Exactly parallel to this, 10 kilometers away, there is another vector, 10 kilometers away. But this vector is parallel to this vector. The magnitude is this vector is also 10 meter per second, and its direction is exactly same. This line and these lines are exactly parallel. Now can you say v1 is equal to v2? Any student? Their direction is exactly same, but they are not on same line of action. This line is known as line of action. Any student can say whether V1 and V2 are same if they are parallel or not.
Parallel, sir.
Yes, Pranav, will they be same or not? V1 and
Yes, sir.
Pranav is right. Any two vectors, even if one vector is in India and other vector is in America, but if their direction is exactly same, they are parallel, it is considered that their direction is also same. Because students, you just think this is north, south, west, east. We want about the direction. Suppose one vector is exactly towards north. This is this is a force of 2 Newton. And here also one vector is exactly towards north, whose magnitude is again 2 Newton. These two vectors are same.
parallel.
These two vectors
Same.
are parallel. At
Hmm.
the same time, they are same.
Same.
A little bit, even 1 degree change in the direction of this vector will not make them same. Then they are not same vectors. This is a special thing about vectors, and velocity is a vector. So, but whoever student answered correctly that the velocity here would be like this, tangent to the path. Velocity at 2 will be again tangent to the path. It will be different. So every single point of this circular motion, velocity is different, speed is same. And students, please tell me, when the velocity is different at any 2 points, what about acceleration? Will the acceleration be there or not? I would like to ask this question from Mehtab. If 2 points are there, beta, on these 2 points, the velocity is different. Velocity is different. Can I say acceleration will be there or not? Sargun,
Sir, acceleration will be there.
beautiful, Sargun. You have good understanding, but increase your sincerity also. You know, Sargun, this is really correct that if at 2 points of the motion, suppose velocity is same, only in that case acceleration will be zero. Remember that? This curve we have drawn, this is velocity, this is time, and let's say this is the graph you are getting parallel to x-axis. Here acceleration is zero. If you are getting this graph or this graph shows negative acceleration, this graph shows positive acceleration, right? So if now in this circular motion, uniform circular motion, every any two distinct points have different velocity. So students, from this we learn that uniform circular motion, the body is accelerated. Remember that whenever a body is moving in uniform circular, from this uniform, what do we know? Any student? This uniform means circular motion. Okay, we know around a circle. And motion means body is changing. What is the meaning of uniform? Any student?
Constant.
What constant? What is constant?
Constant motion.
What is constant? What
It is changing constantly.
which parameter is constant? Anyone? Which parameter is constant? Monrose?
Speed.
Beautiful. Its speed is constant. Wonderful. Uniformly circular motion. The body is accelerated. Its speed is constant, but its velocity is not constant because of this reason. These two vectors are same, but when a particle is going around a circular path, its velocity will be tangent to the this circle. So here it will be like this, here it will be like this. Okay. So now we have few points we learned from uniformly accelerated motion. Number one, you know, when a body moves along a circular path, direction of motion will be changing. Velocity will change due to continuous change in direction, and motion along circular path is accelerated. This motion is always accelerated. Number two, students, when a body takes one round of circular path, then can anyone tell how much distance it is covering in one round? If the radius of this circle is r, how much distance it will cover in one round? 2 pi r. Am I right? Suppose this distance is covered in time t, then what will be the speed of the body? Monrose, 2 pi r distance.
2 pi r upon
Correct.
t.
Beautiful. Speed will be 2 pi r by t meter per second. Everyone write down this. Students, you can't say its velocity will be 2 pi r by t. You can't say, because in uniformly circular motion, the velocity is not constant. Speed is constant. Okay. Now, the last point, some of the examples of uniformly circular motion. This is a string. This is a boy here. With his hand, he's moving the string. There's a stone tied to the string. The string is moving like this, right? He's constantly, moving the stone with the help of this tension. So this is example of uniformly circular motion. Suppose there's a circular path. You know, death well, maut ka kuan. You have heard about death well? There are
Yes, sir.
there are motorcycle people. As long as he's going on one track, as long as he's going on one track, you know it can be considered as uniformly circular motion in one track. When he changes the track, his speed changes. Remember that. His speed changes. So this is very, very important. All right. Uniformly circular motion. Then the satellite in a circular orbit around the earth, motion of moon around the earth, then car is moving on circular path with constant speed. All are examples of uniformly circular motion. Students, let's do a numerical based upon this. This is a clock. Can I say the needles of the clock are also doing uniformly circular motion? Yes, why not? If their speed is not same, every clock will give wrong reading. Okay. The minute hand of the wall clock is 10 centimeter long. The minute hand. The minute hand is 10 centimeter long. Displacement and the distance covered from 10 a.m. 10 a.m. to 10:30 a.m. What is the displacement and distance covered from 10 a.m. to 10:30 p.m. by? He should have mentioned this. He has not mentioned. By the tip of the minute hand. So this is students' minute hand. Where is 10 o'clock? 10 o'clock means our hand is at 10. This is 9, 10, and the minute hand is 10 a.m. The minute hand is longer. It will be like this. Am I right? This is 10 a.m. 10:30, the minute hand will go like this and it will reach here. This is 6. This is 3. Right? So minute hand will complete half revolution and it will come here. Now, how much is the distance covered? This. I'm talking about this distance. I mean, this is the tip of minute hand. The length is how much? 10 centimeters. So this distance covered by him, by the tip of this distance is the distance. And what will be displacement? That is simple. Displacement can be told very easily.
20 centimeter.
Beautiful. Correct. Very good, Pranav. Displacement will be simply when you join the initial position of the body with the final position, that distance along the straight line. This is 10. This is also 10. Beautiful, Pranav. Displacement will be 20 centimeter. What will be the distance traveled? Yes, anyone? What will be distance traveled? Very simple, yaar. Imagine this is a circle. Imagine this is a circle. The radius of the circle is 10 centimeters. So what will be its total circumference? Its circumference will be 2 pi r. Am I right? So that will be equal to 2 into 20
Yes.
by 7 into what is r? R is 10.
10
This is the
centimeter.
circumference. From 10 o'clock to 10:30, the minute hand has not completed full revolution. It has completed only half revolution. So the distance traveled will be half of this, pi r. So pi r will be 20 by 7 into 10 divided by 2. So this is 11. Now 11 2s are 22. 220 divided by 7 centimeter. Am I right, students? 220 by.
Yes, sir.
Now I have one question to be asked from you. Let's see which student answers the question. Students, the acceleration of the particle is constant. Acceleration is Acceleration is constant in magnitude. Imagine students, acceleration is also a vector quantity. Do you know? Acceleration also has direction. Acceleration is not a scalar quantity, but I'm talking about only magnitude of acceleration. That is constant, but not its direction. The magnitude of acceleration is constant, but not its direction. What kind of motion the particle is undergoing? Anyone can answer? Acceleration of the particle is constant in magnitude. Its direction is not constant. What will be the what kind of motion the particle is undergoing? Can anyone answer? अरे simple यार. Uniformly. No, I'm asking about what kind of path the particle is traveling in what kind of path. So it will be a
Circular path.
circular path. Only in circular path it's possible that its acceleration is constant in magnitude, but direction is not same. Every point the direction is changing. Students, I wish you all the best and don't forget to subscribe our channel. Learn CBSC, share with your friends this video. Wish you all the best. See you at 2 o'clock in the evening. Bye.